All right, we are looking at graphing log functions. Okay, and I'm going to go through this. There is one thing we need to change on here. I guess I'll change it when we get to that part. But the parent function of the logs, I wanted to remind you that I gave you this formula chart. See if I can combine these. There we go. Okay, so I gave you this formula chart on Thursday. Those of you who were absent Thursday, I'll get one to you. This is the one that I put on that bright blue cardstock. And at the bottom is the graphs, okay? In blue is the graph of exponentials, the parent exponential graph that we tested on exponentials before spring break. And now here in red is the log parent function. Okay, remember I talked about how these are inverses of each other. So you can kind of see a comparison of them on the same graph. And you can see in exponentials, remember we had the horizontal asymptote. In log functions, that then becomes a vertical asymptote. Because remember, inverses, x and y switch. So if the asymptote was y equals, now the asymptote is x equals. Okay, so you can see the comparison and see how they're a reflection of each other across that line y equals x. Okay, so you've got that parent function here on our notes. Okay, a couple of things we want to identify. Definitely domain and range. You've got to be able to tell domain and range of any graph that you're looking at. Now, when we were dealing with exponentials, we said the domain of all exponentials was always all reals because it went left forever and right forever. Okay, but the range was limited because of the asymptote. Now looking at logs, since it's an inverse and x and y switch, now it's the range that's all reals. See, it goes down forever and it's going to go up forever, but it's the domain left to right that's going to be limited because of this vertical asymptote. Okay, so the range for all logs, so any log function that you are asked for the domain and range on, the range will always be all real numbers, or negative to positive infinity. Okay, it goes left forever and right forever. If it helps you to accentuate this so you see it a little bit better, this asymptote in your graph, okay, your function is not going to go past the asymptote. It's not going to reach the asymptote. So your domain is going to be restricted to 0 to infinity. Now remember, it would be a parenthesis on both of those. Infinity is always parentheses because you can't reach infinity, but 0 is also a parenthesis because it's an asymptote. The graph approaches 0 but never reaches it. Okay, what is the x-intercept on this graph? Where's that crossing the x-axis? At 1. So if you want to make a note, knowing that, having that as a reference is sometimes helpful. So that x-intercept is at 1, 0 in the parent function. Okay, now that's going to move based on transformations, obviously, but that's what we start with in our head. We should start with an asymptote. Let's go ahead and list that asymptote, a vertical asymptote at x equals 0. Okay, so when we are talking about the parent function of a log, we're going to start with a vertical asymptote at x equals 0 and an x-intercept at 1. Okay, and then we'll go from there based on any transformations. Okay, that x-intercept at 1, it doesn't matter what the base of the log is. In this example, they're using a common log. See how there's no base written? Okay, so a common log has an x-intercept of 1. Okay, what I showed you on our formula chart, I used a log base 2 that also had an x-intercept at 1. If you remember, Remember how we said anything to the power of 0 was 1? So the exponential y-intercept was always at 1? Okay, it's the same concept in reverse. The log of, it doesn't matter what your base is, if you're inputting a 1, it's going to be 0. So you can see that. I can show that to you in Desmos to help you see. So I can do log of 1, and it's going to be 0. Now, even if I changed this to a log with a base, okay, if it was a base 2, that's still 0. If it was a base 25, still 0. If it was a base 250, still 0. You get the idea. Log of 1 equals 0. Okay. And I actually think I put that on your formula chart as well up there in the basic log rules. Yeah, log, no matter what the base is, of 1 is always 0. Okay. All right. Oops. Didn't mean to do that. There we go. All right. So that's our parent function. In the parent function, the a value is an understood 1, right? There's no coefficient in the parent function. You want to write that down. That could be helpful. A is an understood 1 in the parent function. Feel okay about the parent function? Okay, so I'm going to zoom out here so we can see all these graphs on this page together. So there's 4 of them. And I want you to tell me, what do you notice? Don't look at equations or anything, just looking at the actual graphs. What's different? What changes from graph to graph? Yeah, whether it's increasing or decreasing is different in some of these. Anything else? So in this parent function, our graph was on the right side of the asymptote, wasn't it? Are all of these on the right side of the asymptote? No, these last 2 are on the left side, aren't they? Okay, so those are the things that are different amongst these 4s. Okay, whether they're increasing or decreasing from left to right. Okay, so this parent function that I started with is on the right side of the asymptote, and it's increasing left to right. This one is still on the right side of the asymptote, but it's decreasing from left to right. Okay, the difference is that a value went from a positive to a negative. See here it says when a is negative, or not negative. It doesn't say when a is negative. It says when a is less than 0, but less than 0 means negative, right? So I'm going to make that note here. Okay. Say a is negative. So when a is negative and you're taking log of x, your graph is on the right side of the asymptote. Oops, I wanted that to be in red. I'm going to accentuate the asymptote here. And it is decreasing. So it is this shape. Okay. And it's because of that negative there. We're not worried about the 2 right now. We'll talk about the 2 later. We're worried about just the general shape of the curve. Okay. So I'm going to add up here under parent function. I'm going to say a is positive. Okay. And you're taking log of x. Okay. You had your general shape like this. Okay, because we know when you have a negative a, it reflects the graph over the x-axis. Okay. So a negative a reflects over x-axis. That's what we want to get out of that. Now, the difference in the next two is that here A is positive again, but where is there a negative? Inside here, right? The X is negative. So A is positive, but X is negative. What happened to the graph? Where is it? Yeah, it's on the left side of that asymptote. So because of this negative here, so a negative inside on X gives us a reflection over the Y-axis. So it flipped over to the left side of the asymptote. So from the parent function's up here, okay? It's still going down forever here along the asymptote. This one's still going down forever here along the asymptote, but now that's on the right side of the graph. So this graph is now decreasing, okay, toward the asymptote. Okay, so when A is positive, but the X is negative, this is the general shape. Now, last but not least, there's a negative in both spots. There's a negative inside with the X, and there's a negative on the outside for A. So A is negative, and you've got a negative X. Both of those means there's two reflections. It's going to reflect over the X-axis and Y-axis. Okay, so it ends up on the left side of the asymptote because of the reflection over the Y, and then it ends up increasing on that side. So there was right here in the one where I just did the yellow, this second to last one, it has the negative in here in the example, but not right here. So this should actually be a negative X as well, like this one. So I'm just going to edit that a little. I'm going to put a parenthesis, negative X. So when you're taking the log of a negative, so your argument is negative, that's going to reflect over the Y-axis. When your A value is negative, that's going to reflect over the X-axis. And then in this case, it's both. So I'm going to zoom out again so you can see all four of those together. So those are the four different directions the curve of your log could be going. So it could be on the right side increasing, could be on the right side decreasing, it could be on the left side decreasing, it could be on the left side increasing. Okay, so do y'all understand the four different directions or the ways it could look? And that's all based on the positives and negatives, inside and outside. Okay, so when you are asked to graph, all you have to do, because you get Desmos, okay, there's a blank page here on the back, so go ahead and turn to the second page to get to this example. When you are asked to graph, there's three things we need to put on this graph, minimum. You can put more. The asymptote for sure. You're going to identify where that asymptote is. and then at least 2 points to help guide the direction of your curve using that asymptote and 2 points. Okay, oftentimes you'll be able to get 3 or 4 points depending on where they are, because we want to plot points that are integer values, okay, not decimals or fractions. Okay, so as a reminder, okay, this is similar to all of our functions we've learned all year. Your a is the coefficient in front being multiplied, and then you have your function, in this case, a log of x. Then you have your minus h, that determines your horizontal shift, and plus k, that determines your vertical shift. Y'all remember a, h, and k? Okay, we've worked with those in every function we've dealt with. So we have a, h, and k, that's where they fall in a log function. Okay, now what that a, h, and k do, we're going to discuss in more detail tomorrow. Okay, for today, we just need to focus on, can I put this into Desmos and get myself a table or look at points on the graph so that I can plot them? And you really should be able to identify your h value and k value. You should be able to identify a, h, and k in all of your equations, even if you're not sure what it does to the graph yet, until we talk in more detail tomorrow maybe. Okay, but the h value is what is subtracted on the inside, remember? Okay, that tells us our horizontal shift. Okay, the k value is what's added on the outside. That is your vertical shift. And then we already said the a value, okay, can tell us if it's reflected or not, but it also tells us if we have a vertical dilation, which that means a stretch or compression. Okay, so on the first page, we talked about what negatives do, but you also have to remember what the values of AH and K do. Now, in the parent function, really quickly, we said that A was 1 in the parent function. What are H and K in the parent function? Is there anything added or subtracted inside or outside the log? No, so H and K are both 0 in the parent function, so that means there's no shift left or right. Okay. So now when we get to these that do have H and K values, they are moving the parent function. So this +1 on the inside, remember, it's the opposite sign that you see here because there's a minus in the equation. So H is actually -1. And then K is +2. And then your A value here, if there's nothing multiplied in front of the log, what is A understood to be? 1. Okay, so you need to be able to identify AHK. Now, you plug this in Desmos, okay, and you can get a table. So I'm going to save us some time and tell you what you get on that table. So if you go to Desmos and you plug that equation in just as it was written, okay, you end up with, we're just going to get a few. And remember, we only want integer values. So 0, 2, 2, 3, and 8, 4. Okay, the values in between those are decimals, so I don't list them. Okay, so I just need a few integer coordinates. Okay, now I should be able to identify my asymptote without Desmos because my asymptote is always going to be where x equals h because it's a vertical asymptote. Write that word vertical again. You have a vertical asymptote at x equals h. We identified h as -1, So my asymptote is at x equals -1. So I should be able to come over here and write at -1 or draw my vertical asymptote. Okay, and then I will plot points that I came up with from Desmos. So at 0, 2, at 2, 3, and at 8, 4. So I can use those points and the asymptote to guide the general shape of this curve here. Now, I should have known the general shape of it, not necessarily the location, but the shape, based on the fact that A is positive and that X inside the argument is positive. So I should have known that it was going to be this shape to begin with, based on those values being positive. Okay, and it checks out. It is on the right side of the asymptote, and it's increasing from left to right. Now my domain and range never changes. If it's a log, your range is all real numbers, negative to positive infinity. Now, the domain is dependent on that asymptote. So my domain is going to vary based on the location of the asymptote. So it's -1 is the leftmost of the graph, and then it goes right forever. But the -1 gets a parenthesis because you never reach the asymptote. It gets closer and closer and closer to -1, but never touches it. Feel okay about that? So let's try it with number 2. So before I do anything, just tell me the general shape. The A is negative. Do y'all see that? Negative A. And then the X in here is positive. So that means it's reflected only over the X. So the general shape of this graph, if I could get my pen to change colors, here we go. Okay, the general shape of this graph should be this one. And that's solely based on the positive, negative values I see. Okay, so we'll check and see if that turns out correctly. So I see that A is -3. I see that H is +1. And that K, oops, I did that in the wrong color. It's doing H in red and K in blue. Well, I don't know why that just popped up. Here we go. Oops, not -1, -3. All right. So I've identified A, H, and K. So my asymptote is at X equals H, which is +1. So I'm going to sketch that at +1 this time. And based on the shape that I think it should be, this should be on the right side of the asymptote, shouldn't it? Should come down along the asymptote and decrease to the right. Okay, so I would go into Desmos and I would plug this equation in and I would get a table of values. Do y'all need me to remind you how to do that in Desmos, or are y'all pretty comfortable with it? Does anybody need a reminder? I couldn't tell if that was a uh-huh or uh-uh. I'll go ahead and show one, but this is the table, the few points that are integers that will fit on this graph. Okay, so let me go to Desmos. So I would type this in, as you don't have to put the f of x equals, just the -3. And then this is a log base 2. So I need to make sure I use the correct log base to get the correct values. So a log base 2, and then it's x minus 1 on the inside, and then -3 on the outside. So remember, when you want a table, okay, you can see the graph over here, but if you need a table, you just come up here to the little edit, and it'll give you the option, click table. Now remember, it always auto-populates here, -2 to 2. Well, the 2, -3 is good, but then you need to keep going until you get some other integers. So I got 3, -6, and then 5, -9. So there's 3 points that are integers. That's how I got it in Desmos. Okay, so if you weren't sure how to do that in Desmos, that's how. Okay, and you can see those plotted here, those 3 points. Your asymptote does not show up graphed in Desmos. You have to know how and where to graph that asymptote. Okay, so those 3 points are at 2, -3, 3, -6, and 5, -9. So now I just sketch the curve down along that asymptote through those points. And that checks out. You can compare it against the graph in Desmos. We knew that should be the general shape of the curve based on the positive, negative values. Okay, so now I just have to give domain and range. What is the range for all logs? All real numbers, -infinity to positive infinity. Okay, what's the domain of this graph? How far left does this graph go? What's the leftmost? 1. The asymptote is as far left as that graph goes, and it's not included. And then how far right does the graph go? Very good. All right, let's try one last one. Okay, it's a little different. This one has that negative on the inside. Okay, the x is negative. Okay, now I want you to see how that's going to affect my h value. Normally, in these two, see how it was x minus 1, so h was positive 1? This was x plus 1, so h was negative 1. It was the opposite sign of what you saw for h. Because this one has a negative in there on x, it's already the opposite. So our h is actually 4, positive 4. Okay, so h is positive 4 here. Now, if that is confusing, anytime you're unsure of h or what it should be, take your argument. Okay, that's what's inside the parentheses, what you're taking the log of. Take your argument and set it equal to 0. And solve for x. How would I solve this for x? How would I move that 4? And then how would I get rid of that negative on the x? I'd have to divide it out, divide by -1. And I end up with x equals positive 4, don't I? Negative divided by negative. And that's my asymptote. My asymptote is x equals 4. And notice it's positive 4. And that's your h value. Your h is positive 4. Okay, so it's a special case here because of that negative in there. Now I can go ahead and say the fact that my a is positive, but this x, this argument, is negative, I know that my general shape, looking at that first page of my notes, my general shape is going to look like this. So it's going to be on the left side of the asymptote, decreasing. Okay, we'll check it in Desmos and make sure we got that right, but that's what it should come out to. Okay, my a is 2, Now, is there a K value here? Is there anything added or subtracted on the outside? So K is 0. All right, now I should be able to answer range before a graph because it's a log. I know the range. Okay, but I'm going to go ahead and graph my asymptote that we said would be at 4. Okay, and then I'm going to use Desmos to come up with some values so I can plot points here. And I'll save us some time and tell you. Now, I'm going to put 4 will fit on here. So I'm going to put 4 points that are integer values that fit here. And I'm going to plot those. So at -4, 6. And then at 0, 4, 2, 2, and 3, 0. So if I connect those, does that support the general shape that we thought it should be? Yeah. It's on the left side of the asymptote, decreasing from left to right. So sometimes if you had a multiple choice question, like on a review or a test, sometimes you can eliminate answer choices just based on the direction of the curve. Like, is it on the left or right of the asymptote? Is it increasing or decreasing? So if you have a good understanding of what those negatives do to the location or direction of the curve, sometimes that can help you just narrow down answer choices. We feel okay about these? Oh, last piece, domain. What's the domain for this one? This one's a little different because it's on the left side. So how are we going to write the domain? Remember, it's left to right. Good. It comes from -infinity, and the furthest right it goes is very good. So when it's flipped over to the left side of the asymptote, the domain starts with -infinity. So just be careful with those. Your practice is just graphing. It doesn't even ask for domain and range. It only asks you to graph. And you first identify, is there a vertical or horizontal asymptote? And if they're all logs, they should all be vertical. So you'll select vertical, and then stuff will pop up on the graph and you move it around. You put the asymptote where it should be, drag and drop, and then there's 2 points that you drag and drop, and it will auto-populate the curve. Okay, so it's just moving those 3 pieces, the asymptote and 2 points, and that's it. That's all you're practicing today. So you're going to use Desmos to help you do that. Any questions? All right, you'll go ahead and get started.